Okay, well, here there are a lot of data, and of course I don't want to go in detail in all of them. But well, to have an overview, as I told you, the idea of the silicon carbide reforms with silicon carbide, or the carbon with silicon carbide, or carbon-carbon. Also, another possibility that obviously are quite good against the oxidation because are already oxidized are the ox-ox, like alumina, for example, reinforced with alumina, alumina fibers, of course, but practically all of them are based in this concept. And why is the reason? The reason are here. Okay, fracture toughness of silicon carbide, I think, is less than 4, and alumina, I have not now the data, but I think it's around that. And through this one, well, we have a really good values. Except, well, probably for the carbon-carbon that is still low, but for the other ones are quite high. Okay. Other important thing that maybe I don't talk so much about that is the density. Okay. Well, this density is really low and will save a lot of weight. That is critical. I mean, in terms of efficiency, of course, if you have to move a plane, for example, that is lighter, yeah, you earn a lot of energy on that. Okay. Here, well, maybe it's not a really big problem, but for other application, it is that it's really hard or impossible until now to have really dense materials. So that it's always with porosity through the methods. Okay. And well, here I told you that I was not sure about the brakes, but this one you need a really high thermal conductivity to release the heat, and then probably, I'm not sure, but probably are made on this carbon silicon carbide. Okay, going in the direction this 130, because you need to remove it. Here, just to mention, it could be great, of course, to have a low coefficient of thermal expansion, but depend if you join with metals or not. This is quite good only for the TBC, but well, this one is always the problem between metals and ceramics. And just to remark here, the maximal temperature service, as you see, for example, the carbon-carbon, is you protect against the oxidation, because if not, of course, you burn out the material, but it works until 2000 degrees or other materials that these go farther than the current superalloys. And well, I think this one is the last slide. It's just to show you, okay, CMCs can be like, oh, maybe it's a dream, or theoretically it works, but I told you now there are several components that start to be done in CMCs, and I'm sure that this is the future. I mean, this one is totally done in CMCs, as is for the exhaustive gases, also this piece, and here's an example for the turbine blades. Many companies are investing now in that one, and from the last years, and now we can do these kind of things. Then I'm sure that this is the future of the materials. Yeah. And yeah, well, I would like to remark, and I'm grateful thanks to Professor Robert Fassen, who works in my institute. He's the head of the department in our institute, and well, he's a really expert in thermal barrier coatings. Whatever you need about that, yeah, you can ask me, and I put in contact with him, because well, he's one of the best ones. Yeah, and yeah, that's all. Yeah, thank you.
Any questions?
Yeah, sure. Sorry, I can. Yeah, you can start.
Oh, okay. My question is about the thickness of the TBCs and the EBCs, because you always said that has to be a thin layer, but is there a limit of the thickness of the barriers?
Of course, it's a limit. If not, that we can do is just coating like that, and then we protect it. But of course, depending on the thickness, you have other problems, and it's a limit. I don't know exactly the.
For example,
the value.
by mechanical efforts, can
of course,
be a problem.
if not, it's like if you do your material already with this material. You don't need the super alloy. But there are other things. Of course, you need a substrate that protects this mechanical stability. The problem always with the ceramics is the same, the mechanical stability. Okay, then, yeah, you need really a substrate. If it is high enough, your coating, at the end it will be break. Yeah. Of course, you protect against the temperature, but nothing else. The limit, to be honest, I have no idea which one is. If you are interested, I can ask. I suppose that it depends on the temperature, of course, and on other factors, but yeah, could be, and I'm practically sure that is around 500, is here, yeah, around 500 microns, something like that. Okay, here I think I put example. Well, here you have one example. For example, the thermal barrier is the 300. Here, well, up to 400 microns, this kind of values. Yeah. Of course, it cannot be really thin, but you cannot go really thicker, like millimeters or something like that.
Okay, thank you.
With the bond coat, it's the same. I mean, you cannot produce a really large bond coat. Also, it has no sense because it doesn't protect really your material of the temperature. Okay. What you see here, the bond coat, well, practically doesn't decrease the temperature or here. It's only to join. Yeah, here for example, here you see is 3 millimeters. Okay, then probably that one depends of the property. Probably in a plane, you need to be really thin, but maybe for other application, I don't know, in automotive or in others, it can go even further. Yeah, but at least at the point that I know, normally it's like 5 microns, something like that. Yeah. No more.
Hola. Sí. I have a question too about the TGO layer that appears when the piece is it's processed, like created. From fabric, it doesn't have the TGO. It starts in.
What happen in the next presentation? I will show you all the processes. Depend how you process. It can be a start to form, but it's not like this thickness. Maybe you produce the oxidation, but this TGO is produced by the oxygen that penetrates, and well, the alumina is moved. I mean, by the diffusion of elements, and alumina it's always formed here. It cannot be avoided, this TGO. It's a problem. And on the other hand, also it protects through the oxidation, because if not, it continue oxidation. If the oxygen achieves the superalloy, this is a really big problem. Okay.
Any more questions?
Okay, then I don't know. 11, it's okay for you, or I think today will be shorter the classes, but yeah. Okay.